Hi guys, so today we will talk about the addendum for the finite volume session. So this is more related to the practical part, and then we will learn how to actually build the mesh, because as I will show you in a second, or maybe I already show you depending on when this is going to be presented, you will see that there is a routine you have to build, that is setup mesh. But the funny thing is that you get inside and there is nothing. So it's basically completely empty, and then you have to just do it all by yourself. Okay? So how do we create a mesh? What is the concept of a mesh? So I will just start with a very simple example. So we just consider our trapezoid. So this is gonna be our mesh. Okay? So the first thing we have to do, this is something we already did last time, is to give some labeling to the nodes, no? So we can start from 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first thing. But now we have a mesh that is not uniform anymore, as we had in the finite difference session. So we need coordinates, and this is the part when mesh actually is entering into this game. So I will start, and we will assume such a geometry. We will assume that here we have something, maybe, I don't know, let's put it 2. Here we put 2. Here we put 1. So these are the dimensions. So we can start just by, and we assume this is the origin in here. So this is 0, 0, okay? So we start and we say, okay, this is 0, 0. This one can be, well, let's say 0 0.6, 7, 0, and this is going to be 2, 0, okay, for example. Then when we go upwards, then we have here what? Just 0, and let's call it 1, and this is gonna be 0, 2. Here is going to be 2. Let's put in here first 2, 1, and then 2, 0 0.5, and then we have to give the coordinates to the center. Then let's put 0 0.7. This is a point. Then something between 0 and 2, no, between 2 and 1, 1.5, and then here 0 0.7, 0 0.7. This is just, I'm just inventing the numbers, just something to make sense, okay? So you can just put a stop in the video and see if that makes sense. So we have already created the mesh because we have given some coordinates, okay? So we can actually split the coordinates in two matrices. So we will call a matrix X, and we call the other matrix Y, so the coordinates of Y. So in here we just put 0, 0 0.7, 2, 0, 0 0.7, 2, 0, 0 0.7, 2. So basically something that you could obtain with mesh grid, for example, but only for X, because Y now we have a change. Then every single column row is going to be different. Here we have 0, 0, 0. Then we have 1, 0 0.7, 0 0.5, and then we have 2, 1.5, 1. So this is going to be an structure mesh. So normally structure meshes are simpler than unstructured meshes in terms of the information that they contain. Here then we know neighbors because the mesh is so structured that we can just assign, we can already have rules to say this node is going to be the neighbor of this node at the south, at the east, at the north, and so on. So this is going to, I will explain right now. How do we do that first? Then we have to assign a third label to the nodes, and this is going to be like an ij coordinate of a matrix. So this ij coordinate, I will just put it, let's put it in red so that not to confuse it. So red is, so I read ij coordinates. Now if you know, forget about the physical metrics and let's imagine this is somehow like a matrix in terms of mathematical terms. So this is gonna be which row? Yeah, first column, first row, second column, first row, third column, and so on. So let me just put this thing in here. We will just put, this is 1 1, this is going to be 2 1, 3 1. Okay, and then we have all the ij coordinates. So what do we do with this? And this is part of something that you may already somehow invented last time in the finite differences class, but in case you didn't, I will just give you some hints on how to use this. So this notation allows me to do the following. If I say I'm standing in the node 5, and I know that the node at the north of 5 is 4, and at the south of 5 is 6, and this is going to be at the east, this is going to west, this is going to be east. But what happens if I refine the mesh, for example? So in here I already refined the matrix. So this is the same. Now we have more nodes in the x direction, more rows in the y direction. So previously we have said that the north of 5 is 4. Now, I mean, there is not even north of 5. We say that the east of 5 was 8. And here we have the east of 5 is actually 9. So imagine you do this in a hard way every single time you create a mesh. That would be insane. I mean, it will be impossible. Okay, so the idea is that the connectivity between nodes is governed by the ij coordinates. So if I go to the 2 2 again here, so this is the 2 2 now, and this is going to be the 1 2, and this is going to be the 2 3. So even if I change the mesh from here to here, I know that the north of 2 2 is going to be always 1 2. The east of 2 2 is going to be always 2 3. So this is the trick. Now what we have to find out is to use any function. So in the manuscript I suggest a function called index. So you actually will give you will give ij, and it will give you the actual number of the node. So we have index 2 2, it will give me, for this example, for the upper one, 5. But if we are in the lower one, index 2 is going to give me 6. What it means is that the function index depends on the mesh. So this function index is not the same function index as this one. So we have to build an index function that is dependent on the size of the matrix, on the number of nodes in X and the number of nodes in Y. Then when you consider the stencil, then you just have to type, for example, imagine you have a system called T, and you are standing at the node P, and the node P is 2. Okay, so you will go and say index 2. And it will give you the temperature at that node. Because remember, you can think about this as a kind of a vector. Remember that when we go into the matrix vector notation, the temperature is not going to be anymore a matrix but a vector. So in this case, in the first example, or let's assume this is from this example. So this is actually the index of 6. And if I want to know the north of this, then you just need to go and say, I need this is P and this is gonna be the north. So P here is 2, just as an example. Then it's gonna be index, and then what is at north of 2 is 1, 2. Which basically the function is gonna tell you I need a function T5. I will just put this arrow here just to not make in relation with this. This is different. Okay, so this is the trick. I don't want to tell you anymore because the idea is that you go and experiment your own stuff to create the mesh. I will explain also in the class that there is a function that is telling you the coordinates of the upper set of boundaries of nodes. So that function, what it means is that to create a mesh, you just need to know this function. So somehow like the equation of a line. Then you just position your nodes at this line depending on the distance, depending on the resolution of the mesh, and then you just create the nodes in the columns. Okay, I will not say anything else. Okay, so have fun. This is gonna be a very nice session. We'll be just the whole day connected and working on this. Okay, well, bye bye.